Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called The Mill by Fuchsia, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have digits along a grade line summed to the same value as the circles on either end combined. So therefore, this digit must equal the same as these two digits, because the digits along the gray line sum to the same value as the circles on either end combined. So this is equal to the sum of these two digits. So for example, if this were say a 5 and this were say a 2, then this would have to be 7, because these two digits the digits along the line must sum up to the same sum as the two circles on the ends. And we have something similar here. We could have, so say we had 5, 7, 2. Say we had something like, I don't know, 6 and, I don't know, 8, then this would have to be 9. Because 6 and 8 add up to 14, which would be equal to the same sum as 5 and 9. So that's how these gray lines with circles at the end work. We also have box borders divide the blue line into segments with the same sum. So these two digits must sum up to the same sum as these three, which must sum up to the same sum as these two digits here. So it's something similar to these. Interestingly enough, we also have digits connected by a V sum to 5 and digits connected by an X sum to 10. Not all possible XV clues are given. So for example, if this were 2, this would have to be 3 and this would have to be 8. Because these two digits must add up to 5 because there's a V in between them. These two digits must add up to 8 because there's an X in between them. Sorry, must add up to 10. And therefore this must be 8 because they have an X in between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, let's start with the central box here. 5 can never be next to a V or an X. Because how do you add up to 5 with 5? It must be 0 and 5 to add up to 5. How do you add up to 10 with 5? It must be 5 and 5, neither of which can occur, because 0 is not allowed in normal Sudoku, and you can't have two 5s in the same row or column or box by normal Sudoku rules. So where is the 5 in the central box? It has to be here, which is why I placed that as a 5. Now, 5 plus another digit is always going to be 6 or higher, right? In normal Sudoku, because you can't have a 0 available. So 5 plus another digit means these are all going to be high digits. Well, that means those which are the 6 through 9. That means to add up to 10, they must add up with low digits to add up to 6 through 10. Also, these have to all be low here, because low plus a 5 adds up to 6 through 9, right? You can't have 5 plus a high digit adding up to another single digit, because 5 plus at minimum 6 would be 11. 5 plus 5 adds up to 10, which none of which are digits. So this is low. That makes this low here to add up to 5. These are both low. This is low. This must be low and high here. This is low and low. This is low and high to add up to 10. Well, In row 7, we have 4 lows already accounted for. So the rest of the box cannot be low. This can't be 5 either, so this must be high, which makes this a low here, and we already knew that because these two are add up to 5. Remaining digits in row 7 are either high or 5. This is high or 5. These two must sum up to what 2 low digits have to add up to plus a high digit. That's minimum 1, 2, and 6. That doesn't tell us very much, though. These are all low. So this is a low, which these 2 digits must add up to 5 plus that low. Well, this can't be 9, because if this is 9, this would have to be 1. And 5 and 1 is already less than 9 by itself. What about 8? 8 can't be here. Same problem. 5 and 2 is 7, which adds up to less than 8. So this has to be 6 or 7 here. That's 3 or 4 there. 5 and 3 would force this to be 7 and 1 here. That does work, potentially. What about 5 and 4? 5 and 4 add up to 9, which forces this to be 6 and 3 then. So this has to be 1, 3 with 7 or 9. So this must be 2 or 4 here, which makes this 1 and 3 there. Okay. So how does this work? If this is 3 and 7, this has to be... Okay, so this has to be 1 or 2 here, guaranteed. This is low, so therefore this must be high here. If this is 5 and 3, this is 7 and 1, so that's 9. That's 4 and 1 there. That works. That's 3 and 2. If this is 4 and 6, this is 3 and 7, which makes this 2 and 3. So these 2 digits are always the same. Interesting. These 2 add up to 5, therefore these 2 digits must add up to 5. So this... Okay, so these 2 are the same. We'll mark that as an A. These 2 add up to 5, and these 2 add up to 5, so these must be the same. So that's B, and then this was marked as C. So this must be D there. So B and C are here. This has to be then an AD pair here. To add up to 5, because this is guaranteed to be B, that's guaranteed to be C. So this is an AD pair. This cannot be A or D, it's B or C. Interesting. This is an AD pair, so this has to be a BC pair here. These pair of digits cannot be here or here. So this is A with its high digit here. Whichever one is here cannot be either of these, so it's one of these two. Whichever digit here cannot be here, it's one of these two. Okay. Hmm. To add up to 10 here, this cannot be B or C. Can't be B or D here. So this has to be an AC combination to add up to 10. C obviously can't be here. C could be here, though. Or this could be A with its 10 adding up to this 10 equivalent here. Okay. Oh, this is D here. So these two add up to whatever this is. But if we add D here, then this would add up to the same amount. So this cannot be D, this has to be A. So this is guaranteed to be A here, which means this can't be A, that's D there. This is 5 plus C, so this cannot be C here, it's B. Because we have the same problem, right? So therefore, this is B. We have B plus this digit equals that digit. C plus this digit equals that digit. A plus this digit equals that digit. So D cannot be here. D is one of these two. We know this is a BC pair. We don't know which one's which. C has to be here. C has to be one of these two. So C has to be essentially one of these two digits here. B is here, B is here, B can't be here, so B has to be one of these two digits there. Hmm. So B is here. B cannot be either of these. So this is the high digit, which adds up to 10 with B. So this cannot be B with the high digit here. So B has to be one of these two digits there. So this is A with its high digit. That means high digit here, high digit here. One of these has to be the high digit with A. A has to be one of these two. Huh. Okay. This is getting kind of convoluted, I feel. Okay, what happens if this is 4 and 6? 4 and 6, 4 and 5 add up to 9, 6 and 3 add up to 9. So this would be equal to 3 plus 4 here. So this would be 3 and 2. 3 and 4, and that's 6. This would have to be at least 7. So 3, 4, and 7 add up to 14. Right, and that's how we solve it. So 3, 4, and 7 at minimum adds up to 14, which these two digits are not going to sum up to. Because this is a low, which is at most 4, plus 9 only adds up to 13 at most. So this cannot be 4, therefore this must be 3. That makes this 3 and 7 to add up to 10. 5 and 3 add up to 8. 7 and 1 add up to 8. So A is 1. So this is 1 and 9. That makes this 4. So we have 1 and 3 here. This is 3 and 2. This adds up to at least 1, 3, and 8. That's 12, which is the max these two can add up to, since this is 3 at most, and this has 9 at most. And therefore, oh, sorry, it could be 1, 3, and 6 also. Ooh. So, oh, this can't be C because these two add up to 10. And these add up, sorry. So this can't be C, this has to be B, right? Because these two add up to 10. If you have 7 here, that would, if you have 3 here, this as a C, then these would have to be both 7s, which is a repeat in the row, which is not allowed. So B cannot be here. B has to be here, B has to be there. So B's are all, so B has to be here, which means this can't be B. So B therefore has to be 3. And this must be C, which must be a 2. So these are 2. 2 and 8 add up to 10. This is 3 and 7 adding up to 10. This can't be 8 either here, so 8 has to be here, which makes that 2. Therefore, D is a 4. So this is 4, that's 6. And 3 and 5 add up to 8. 5 and 4 add up to 9. 5 and 2 add up to 7. 5 and 1 add up to 6. And this is 1 and 9 to add up to 10. This has to be 3 and 9 to add up to 12 here. These two digits add up to... Where is 9 in row 7? Can't be here because of 9 in the box. Can't be here because 9 and 3 add up to 12. So 9 therefore has to be there, which means this is 9. Remaining digits in row 7 are 5 and 6, but if we had a 6 here, that would be 6 and 6 to add up to 12, and that would be a repeat, which is not allowed. So this has to be 5, which means this can't be 5 there. That's a 6. This is 6. That's 5 and 7 adding up to 12 here, which is a sum of what these 3 digits add up to, and the same as these 3. If it's A, it's 1 and 9, but we can't have a 9 here because of 9 in the box. So to add up to 10 here, we can't have 1, 9, no 3, 7, no 4, 6. It must be 2 and 8. And this can't be 2 because of 2 in the column, so that's 2, that's 8. This must be 3 and 7 to add up to 10. Okay. Ones. Remaining digits in... where should we start? Let's do column 6. We have 1, 5, and 9. 1 can't be here because of 1 in the box. And that's all we have. How about column 5? We have 2, 6, 8, and 9 remaining. Okay. No 2 or 8 here because of 2 or 8 in the box. That means one of these, at least, has to be 2 or 8. Well, we can't have 2 here, because if this is 2, 4 and 2 add up to 6, we don't have 5 and 1 available here. But 4 and 6 add up to 10, but that would be 5 and 5 to add up to 10, so this can't be 6. 4 and 8 add up to 12, but then 5 and 7 would have to be there. So this cannot be 4 and 8. That leaves this as 4 and 9. That's 13, which makes this have to be 8. to add up to the same sums. This 9 eliminates 9 in the rest of the box and column. So this can't be 9, that's 6. This is 1, 5 as a pair, which eliminates 1, 5 in the rest of the column, so this can't be 5, that's 9. 6 eliminates 6 here, so that's 2. Okay. Remaining digits in this upper central box. We don't have 1, 5 available, so it's 3, 6 as a pair. That leaves the remaining digits in column 4 as a 4 and 5 pair. Okay. Remaining digits in this lower left-hand box. Well, 7 can't be here because of 7 in the row, so 7 has to be there. That leaves the remaining digits as 1, 5 as a pair. That eliminates 1, 5 in the rest of the row, so this can't be 5. That's 4, that's 5. Remaining digits in row 8 then are 6 and 8. Remaining digits in row 9 are 1, 3, and 4. This can't be 1 or 3 because of 1 or 3 in the column, so that makes that 4. Means this can't be 4 there. Remaining digits of column 7. We have 5, 6, and 8. And this can't be 5 because of 5 in the row. This can't be 8 because of 8 in the row. So if we have 3 and 6 here, that would force this to be 5 and 4, which is possible. If we have 3 and 8 here, that forces this to be 5 and 6, which is possible. So 6 has to be one of these two digits, right? Because 3 and 8 add up to 11, 5 and 6 do also. 3 and 6 add up to 9, which 5 and 4 also do. Okay. Remaining digits. So 6 can't be here, 6 can't be here. That doesn't really help us much. Remaining digits of column 3. We have 1, 5, 6, 7, 8. No 1, 7 here, no 8 here, or 6. No 6 here, because, or 5, because of the 5 in the row, and one of these having to be 6 in the row there. No 8 here, and then everything else is fine. 2 and 1 doesn't work because that adds up to 3, and 5 was already greater than that. 2 and 7 add up to 9, so that could be 5 and 4. 2 and 8 doesn't work because that adds up to 10, and 5 and 5 would have to be here, which is obviously doesn't work. So this must be 2 and 7, adding up to 9, which is the same as 5 and 4. That eliminates 4 here, so it's 6. 5 and 6 add up to the same as 3 and 8. So it can't be 8 there. 7 eliminates 7 in the rest of the column. Remaining digits in row 5 then are 1 and 9. This can't be 9 because of 9 in the box, so that's 1, which makes that 9. 1 eliminate, or 9 in the, yeah, 9 in the box. 1 eliminates 1 here, so it's 3 and 1. That's 3 in the corner. We celebrate because we're close to solving this. I think everything's done now with the center, so it should just be normal Sudoku now. Okay. Remaining digits. Let's do row 3. Ugh. We have 2, 5, 6, 8. No 2 or 8 here because of 2 or 8 in the column. No 6 here because of 6 in the column. No 5 or 6 here because of 5, and no 5 or 6 here because of 5, 6 pair in the column. Or sorry, in the box. 6 eliminates 6 here, so that's 8 and 6. 8 eliminates 8 here, so it's 2 and 8. This can't be 2 or 8 because of 2 or 8 in the row, so this is 5, which makes that 6. 5 and 6 eliminate 5 and 6 here, so that's 1. No 1, 5, or 6 here, it's 8. 1 eliminates 1 here, so it's 5 and 1. 5 eliminates 5 here, so it's 6 and 5. 6 eliminates 6 here, so it's 3 and 6. 1 eliminates 1 here, so it's 5. This can't be 5 or 8 because of 5 or 8 in the column, so that's 6. 5 eliminates 5 here, so it's 1 and 5. Where is 1 available in this left central box? Cannot be here because of 1 in the column, so 1 has to be there. And that was, yeah, we had 8 ones anyways. That's another way of putting it. 2. Where is 2 in row 2? Can't be here because of 2 in the box. Can't be here because of 2 in the column. So 2 is there. That gives us 8 2s. We know where the last 2 has to be. It has to be there. We have 8 3s. We know where the last 3 has to be. It's there. 4. In column 1, 4 cannot be here because of 4 in the boxes, and that leaves that as a 4. We don't have enough information to disambiguate here. So 5s. We have 8 5s. We know where the last 5 has to be. It's there. 6s. We have all the 6s. 7s. In row 4, 7 has to be there, but we don't have enough to disambiguate the rest. 8s. In row, we have 8. Do we have 8 8s? We do have 8 8s, so the last 8 has to be there. 9. In column 8, 9 cannot be here because of 9 in the box, so 9 has to be there. That gives us 8 and 9s, so the last 9 is there. And then we look at 4s again. 4 in row 6 has to be there. Cannot be here anymore, so it must be there. That's 8 4s. Yep, and then that leaves the rest of the digits as 7s. And that's a solution. I guess I shouldn't have done these that much. I didn't really need to do that. I just needed to basically calculate this out. Sometimes you have to do that. That would make things much easier. And it made it much easier in this case. It's basically just trying things out and saying, what happens if we make this 4 and 6? Well, that makes things a little bit tough on this part, right? So, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.